My name is 09Wessely. I'm a postdoc in the HCI engineering group at MIT CSAIL. And I want to talk today about one of our most recent projects that we just published and at a conference received the Best Paper Award. And this is about reprogrammable multicolor textures. So like, what is this and what it is good for? Imagine you want to buy a car and you're not really sure what kind of color this car actually should have. So you want to have it in black and yellow and green, but you want to see it, of course, in advance. So what you can do is you can go to a seller, and the seller can show you a digital model of your car. And there you can quickly switch between different colors, between different designs, between different textures. And in the digital world, with the digital model, this is extremely simple and easy. But on the other hand, it would be, of course, great to have it also in the physical world, so that you can actually see a three-dimensional car in front of you, a real car, and you can just switch through the different colors and through different designs. This is, of course, very expensive, because pretty much every time you would have to apply a new paint, which takes a long time and is expensive. So and we wanted to find a solution for that and actually make it possible that you can have a coating, a color, where you can just switch through different designs, through different colors, and see what an object looks like without actually repainting it or buying a new one all the time. So let me see how this works. So what we did was we developed a color-changing material. So this color-changing material is pretty much a coating, something that you can spray on pretty much any kind of object. It's actually based on a coating for cars that you can just spray on them. So and what you see here are 2 times the same object. On the left side, you see a zebra black and white pattern that we programmed pretty much on this material. Then we erased this entire color and reprogrammed it to have more colorful square shape pattern on its surface. So I wanted to show some application examples, what you can use this for. So it's not only about cars, of course. Since this is a coating that you can spray on pretty much any kind of object, you can also spray it on shoes. And every day you can have a new design for your shoes. So again, this is the same shoe, and in a process that takes roughly 30 minutes or so, we just erased the texture that you see on top and then reprogrammed it to have the texture on the bottom. The same works if you want to personalize your phone case, for example. So all 3 is, again, the same phone case. And we choose, this is actually some holiday picture when I was in Tokyo. So I could directly use it in one of my publications. Then such a design. Then here, we have something from San Francisco. And we just, reprogrammed it all the time. So we actually didn't really buy a real car. So we actually just took, a model car. But we sprayed the coating on it. And we, tried out different designs, one super cool one with a flame, and, one with, flowers, because flowers are awesome. Okay, and now I want to go a little bit into detail. This, of course, sounds like magic. So is it actually true and is it working? So the magic behind it is based on photochromic dyes. So photochromic dyes have the property that they have 2 different states. They can switch between being transparent to being saturated with a certain color. So here, for example, you see 3 different ones. One is blue, one is red, one is yellow. At the moment, it is transparent, but if we activate it with UV light, it actually gets saturated and gets a color. So here, I brought to you a video how this looks like. So this here is this car coating, this car lacquer that we use, and we mixed cyan, magenta, and yellow photochromic dyes in it. And now, if you activate UV light, we see how it instantly changes its color and becomes saturated. So and this process is actually reversible. So what I just showed you is using ultraviolet light, and this one is saturating this transparent material. With visible light, you can also reverse this project. So going from a saturated state, again, back to a transparent state. So and you can do this over and over again. So this is repeatable as often as you want it to do. But if we have a coating and we want to test out different designs, it's of course not enough if we have just 3 example colors here, having magenta, yellow, and cyan. So it would be actually super awesome if you would have the full color spectrum, that we actually can realize every kind of texture and every kind of image that we want to project on an object. So our idea, what we showed in this publication, was that we can mix these 3 dyes together. So pretty much we have one coating that contains cyan, magenta, and yellow particles. And each one of those particles can be activated and deactivated. And I've shown you like here, I brought you here some examples on which kind of colors you can achieve with this. So cyan, magenta, yellow, of course, these colors are not selected like completely randomly, but with like cyan, magenta, and yellow, you can cover a large color spectrum. It's actually what you have in inkjet printers. So inkjet printers like work with like cyan, magenta, and yellow, mix it together, and then you can like create pretty much any kind of color that the human eye can see, almost at least. So, but like to actually achieve this, that we can control them individually, we had to like do some research on actually how these dyes behave under different visual lights. So what you see on the left, the dotted lines are an absorption spectra of these dyes, and you can see that at different wavelengths, so pretty much at different colors of visible light, they absorb more or less energy. So they deactivate faster or they deactivate slower. And we've seen that, for example, yellow dye gets deactivated very quickly with blue light, while, for example, the magenta dye gets activated very quickly with green light, but not by blue light. And this is pretty much the trick behind it. So if we shine blue light on the sample, we just deactivate yellow, but leave magenta and cyan pretty much untouched. So we can then say, like, if we have a mixture of 3 different colors, we can set yellow to 20%, cyan to 80% saturation, and magenta to 50%, and then get like a certain specific color in this color spectrum. To do this, like, we also wanted to make it actually affordable and such that pretty much everyone at home can do this, like without having a $1 million wet lab at home or something like that. We implemented this whole technology into a projector system. So we actually just took like an off-the-shelf projector, which contains like a red, a green, and a blue LED. We had to implement like an optical filter for the green light because we've seen that the spectrum of green light is like quite broad, and it actually affected other dyes. So we narrowed it down such that it only affects like the magenta dye. So, and you can like see here like actually what happens like to such a coating. So on the left side, you see the coated object. Here on the projector, it's like quite dark, but actually it looks more like a deep brown, I would say. Then we projected an image onto it, and on the right side, you see like how these color changes like over a gradient. So this here is now like a phone case. This is like the phone case that I also showed you as an application example in the beginning. This here is now activated, so it is in a dark state, and now we want to selectively deactivate the photochromic dyes that are in this coating to get like a certain texture that we want. So for this, like, we have this projector, and we project pretty much like a video. It's an animation of light onto the surface until it is like finished in its treatment, and then like has the design and the color that we want to have on its surface. So this looks like this. So, and after this process, it's finished. You can then take it out, and you can use it for the entire day as you wanted to, as you like to. And then the next day, you can like put it back into our device and select like a completely different texture, a completely different design to it, and just like reprogram it from scratch. So the same is also possible with shoes. Does it sound? Yes. So like instead of like buying the same shoe like 3 or 4 times just because you wanted to have different designs and different colors, you can just like put it into the device, and every time when you have like a new inspiration or like the new your new Netflix series come out and you want to have like a design of Money Heist, for example, on it, you can just like apply it onto it. So, and this is now our famous car model. Again, it's like not real, it's just like a model. So, and to make this like 3D, we also like implemented like a turntable. So pretty much everything is automatic. You just take your object into this device, click on Start or like click on Export, and then everything is done automatically. So, and this is how our system looks like. So you see like on the right side, we have like this platform where we can put the object. At the moment, it's like quite small, so it has like the size of like for a model car or for a shoe. But of course, like the system can be extended as large as you want to. Then we have the DLP projector, which is there for like desaturating the photochromic dye for deactivating it, and the UV light for activating it. And this like makes this process reversible. We can activate and increase the saturation with the UV light and deactivate it with the DLP projector. So also like this material is affordable, and it's like very easy to produce. So like all that you need are like vials, the automated lacquer, then these photochromic dyes, they are commercially available, you can just buy them, a beaker and a mixer. So like you mix together the lacquer with the photochromic dyes, then you have to mix it for 30 minutes, and then it is pretty much like ready to go. You do this for all three kinds of dyes, so for cyan, magenta, and for yellow. Then you do the magic activation with UV light. And then in the end, you pretty much just like mix it together. And then it's like ready to use. You can then put it into an airbrush system, for example, and just like spray it on the object that you would like to augment. So like in our recent publication, we focused on airbrushing things, because airbrushing it is contactless. It has the big advantage that pretty much you can take any geometry of an object, you can just like spray it on a surface, and it's ready to go. On the other hand, it would be also awesome if you would actually implement it into fabrication technologies. So for example, in 3D printing, if we would have a photochromic filament for SLA printing, if you could like add it to like a resin and then 3D print. Also like for fabrics, like for clothes, for this industry, it would be interesting if you could actually like bath a fabric into a photochromic dye and then have pretty much like a shirt that like we can redesign and recolor every day. So at the moment, we have like a couple of challenges. So like this was like pretty much like the first work in this area. And there are like still like a lot of challenges left. So at the moment, we work pretty much with the dyes that this company where we like bought them from actually provides us. So and the problem is we need like a good magenta, a good cyan, and a good yellow. While the yellow is like pretty good, cyan and magenta is like not really a cyan. So the cyan is more blue, and the magenta is actually more a red. So this offset actually shrinks our available color space. So there are like certain colors that we are not able to reach at the moment, but we are like already working on some improvements on this process. So like we also like found the beta cyan, but this was like highly experimental. Like we found some professor in Japan who sent us this, and there was just like 0.5 gram available. So it worked great, but of course it's like not accessible. No? So like you always need to ask this professor, and you can't really buy it. So the next thing is also, at the moment, transferring a texture to an object is a process that takes up to like 30 minutes, 40 minutes. It depends like a lot on what kind of colors you want to actually create, and it depends on the size of the object. So the speed of this process is highly dependent on the intensity of the light source. So we wanted to make it accessible. So we used a projector and a UV light that you can just buy, and it costs something like $500 maybe, and you're good to go. But of course, like with like better hardware, with more expensive hardware that can produce like a higher brightness, you can accelerate this process, of course, a lot, and like go down to like 5 minutes, 1 minute, or maybe even like an instant transfer. So, and the second thing is, like I told you that like we deactivate this color with visible light. This means, of course, also like the light that we have right here in the room at the moment, or if you go outside, is also deactivating this dye. So far we have like some good experience with it. So up to like 30 days, like a little bit longer, the texture actually stays with saturation on the object, but at some point, like it loses contrast. So one solution to this is like actually like having some kind of a method to like refresh the contrast, that you can just like put it back into the device and it just like increases the contrast again. But we are also like looking into like what we actually can change on the material side to make like this material like more robust to environment light, to sunlight. So, and like with this, I want to like finish my talk, and I'm actually super on time, just 30 seconds. So yeah, thank you very much. Thank you.